Howdy! My name is Tyler, and I'm here today on behalf of the Adhesive Metal Powders Group to talk to you about our engineering capstone project. Now, to get things started, our project attempts to see the adhesion of a powder metal compact and wrought metal sheet material through a process known as sinter bonding. Now I know what you're thinking. What the hell do any of those words even mean? Now, before you skedaddle on out of here, allow me to explain some things. A powder metal compact is a material created through powder metallurgy. Powder metallurgy is a manufacturing process that takes fine metal particles and turns them into a solid, three-dimensional part. Now again, I know what you're thinking. Holy shit. Is this magic? Well, sorry to break the news, but there's no sorcery to be found here. You see, what happens is during manufacturing, these fine metal particles are smashed together, and they end up forming a solid compact. These compacts can be made quickly and efficiently, but they happen to be very porous and end up breaking easily like chalk. To address these issues, manufacturers heat these compacts in furnaces in a process known as sintering. Sintering solidifies the part, decreasing porosity and improving its overall structure. F***ing awesome, right? Now, what is a wrought metal? Well, this would be any metal that has been manufactured by mechanical deformation processes, such as forging, hot rolling, or strain hardening. These metals can be manufactured on a much larger scale than powder metal parts, but they happen to not be able to achieve the more complicated shapes. Alright, so how did we approach this problem? Well, to get to that, I have to explain.
Fucking dumbass! Jesus fucking Christ, shut the fuck up, you already fucking babbling baboon, you fucking idiot! Oh my god, shut the fuck up!
What do you mean?
They don't give a shit, get to the goddamn point! Jesus!
Okay. My foul-mouthed friend here is named Jimothy. You know, he's a little bit of a goober. But, you know, I get his point. In our first experiment, we attempted to adhere fine iron particles to a solid iron tray using sinter bonding. Sinter bonding uses the principles of sintering to bind different materials together. For sinter bonding to work properly, the said materials need to have similar thermomechanical properties. Properties such as chemical composition and coefficient of thermal expansion. So, once we determined that the properties between the powder and the tray were similar enough, we spread this powder smoothly along the surface of the tray. And then we heated the tray up in a furnace, raising it at a ramp rate of 15 degrees Celsius per minute to a max sintering temperature of 950 degrees Celsius. We held at this temperature for approximately 30 minutes and then cooled the tray using a furnace cooler. Our end result? Adhesion was achieved. So I guess problem solved. We can just go home,
Hey,
Jimothy.
man, is it getting a little bit toasty in here, man?
Yeah.
Whew. Oh, man.
I know, man. Just kind of.
Oh, man.
It's getting steamy.
Oh, man, oh, man, oh, man, I'm on
Steamy
fire.
here.
I am on fire! Oh my god, it burns! It burns! It burns! Help me! It burns! Ah! Motherfucker, I'm oxidizing! Holy shit! It's peeling off my skin! The rust is peeling off my skin! Oh my god, help me!
Jimothy's dead. So let's talk about oxidation. Throughout our entire project, oxidation was a primary concern. For all you non-sciencey folks out there, that's basically a pretentious way of saying rust. Thus, when testing adhesion levels, we had to employ a variety of tactics. First and foremost, we upgraded our furnace. All of our compacts were sintered in a nitrogen-reducing atmosphere to minimize chances of oxidation. Additionally, we began to employ a preheat method. In this method, we took a singular compact and our wrought metal tray, heated them separately in the same furnace for 1 hour at a lower temperature, then removed them, placed the compact back onto the tray, and heated it at the max sintering temperature for the remainder of the experiment. What this method was helpful for doing was removing oxidation between the compact and the surface layer of the tray. Lastly, we used surface roughening to increase the adhesive surface area between the compacts and the tray. In our latter experiments, we compared samples that had no surface treatment to samples that had been roughened with 320 grit silicon carbide sandpaper. So, by sifting through our project results, what can we say that we learned about using sinter bonding as an adhesion method between a powder metal compact and a wrought metal tray? Well, we can say that we failed. Nah. I'm kidding. Yes, our experiments suffered many shortcomings. We were never able to fully remove oxidation, and our experiments achieved minimal adhesion at best. But through our trials and tribulations, we ended up learning some valuable lessons. Firstly, both preheating and surface roughening increased the adhesion level between the powder metal compact and the tray. Similarly, surface roughening helped to make the materials structurally compatible by increasing the adhesive surface area between the compact and the tray surface. Additionally, we found that fine iron particles strongly adhered to the tray throughout all of our experiments, especially when compressed. All in all, future experiments in this project would need to focus on oxidation removal. At high temperatures, iron has a high affinity for oxygen, making it difficult to avoid. A stronger atmosphere would be needed for future experimentation. Now, I think that about wraps things up. I want to thank you for listening to my lecture and give a special thanks to Metal Tech Incorporated for sponsoring this project. That's all, folks. Adios.